This is probably the hardest problem in the problem set here, and because inclined plane, pulley, friction, everything. By the way, this is supposed to be M2 right here, the 6.75. So the free body diagram on this force here is the weight of this hanging mass. And remember, with pulleys, it bends the axis. So we're going to call this the positive x direction. Okay. So then we set up, like usual, the inclined plane for this part of it. Just like that. So force normal is going to be equal to mg cosine theta in this case, not mg. Mg sine theta is the component of gravity pulling me down the incline. Now in this problem, which way is friction? Since the whole thing appears like it's going to roll this way, that means friction is impeding my motion. So friction would be that way. Now we don't know that for sure, but I'm guessing that because of how much more massive this is. It is possible that this mass is big enough so that mg sine theta is bigger than m2g. In any given problem, you'd have to compare how big this is compared to that, because that will determine if we go this way or that way, and it switches the direction of friction. So you have to be a little careful on that. We're going to guess that, and I think I'm right. So that's the correct free body diagram. So we want to do a net force equation on this. So in our x direction then, the players here, now notice tension is not showing up. And the reason is tension's pulling this way on that block, but it's pulling this way on that block. So remember, tension's an internal force. It creates no net force at all to this entire system because it would cancel each other out. So really we have m2g driving the show here, and he's 6.75 kilograms, so he's probably going to make everything go clockwise here, minus friction, who is working together in the same direction as the component of gravity, not mg, but mg sine theta. Okay. Then in the y direction, our y equation looks like this. Net force in the y direction. Technically, he is in the x direction, so even though he looks vertical, he's really in the x direction as we've redefined it. So this, remember, is our y direction in an inclined plane problem, so it's Fn minus mg cosine theta. Okay, so all that stuff. Now, this is going to help me here because mg cosine theta equals Fn, so I'm going to be able to plug this in for Fn right there. So now we're just plugging and chugging, as we say. Ran out of space here. Plug in all these numbers. Okay, add this over here, cosine of 30. That goes with this term here. That should be sine, actually. Sine of 30. So you plug in the numbers and you should come up with an acceleration of 4.36 meters per second squared. Now for the second part, what you want to do is find the tension. To find the tension, what we want to do, since tension is an internal force, it's not in our equations for the whole thing, we have to pick a part of the whole thing. We could pick this guy or this guy. Tension's external to him alone. Tension is external to him alone. So if we just analyze either one of them, that gives us tension in our equation. This is easier because it doesn't have as many forces with friction and whatnot. So let's just pick M2, and we're just going to redraw M2 here. And it experiences tension up and its weight down. And that's all it knows. It doesn't know anything about what's going on in the incline and things like that. So the difference between those two forces is the net force. And we know that this one must be bigger because we accelerate around, right? He's accelerating this direction. We defined that direction, remember, as positive. This is a common place where people make mistake. Because earlier in the problem we said this direction is positive. We got a positive acceleration here. This came out positive. So this is the direction, this is the positive direction. So we do our net force equation here. We're technically in the x direction as we defined it in the problem, not y. And so it's m2g minus t, not the other way around because of the way we assign direction. You'll make a mistake if you do t minus m2g because you'll see what happens next. So what happens next there is we put in just m2a equals this, and what we're going to do then is we use our acceleration from the first part and we plug it in there. Plug in m2, plug in g, and now we can solve for t. And we would have gotten the wrong answer if we'd switched these and messed up our directions. So we should come out with 36.7 newtons. Ta-da!